Welcome, ladies and gentlemen, to Part F. Now, let me explain this to you. This is going to involve somewhat of an algebraic trick. Yes, some mathematician worked on this forever and ever and ever, along with others, trying to figure out how to get this, and through manipulation and other trial and error, working through it again and again and again, they came up with different viewpoints and ideas. So this does involve an algebraic trick. So it's not going to just happen right out of thin air. This came by way of the discovery of an algebraic trick. Let's begin step by step. Well, the first part of proving this is we're simply going to start out with the absolute value of x as the beginning of our mathematical trick. Now, the next step I'm going to do, I'm going to subtract 0 from that. I'm going to add 0. By adding 0, I don't change the problem at all. That's the next step in our algebraic trick. So, now we're going to go the absolute value of x plus 0. By placing 0 in there, I am not changing the problem at all. There goes the beginning of our trick. And if you kind of look at this, we kind of know we want x minus that y. We want the x minus the y, so we know we're going to want that. So the next part of our trick, coming down, what we're going to have now, we're going to have the absolute value of x minus y plus y. Because y minus y, there goes our 0. And I'm going to put this in parentheses. There goes part of our x minus our y. Remember, y minus y is still 0. So we haven't changed the problem, because now, by using an algebraic trick, we just use another expression to represent 0. Take a close look at that. Take that in. There goes our algebraic trick. Some mathematician along the way thought of doing it that way, saw that perspective, says, oh, let me try this. I have an idea. Let me try and let me see if it works. Based on everything that I've learned, up to that point, and all the other tools that I have available to me. So now, once he got to that point, he says, oh, I wonder what can I do now? He looked at this and he says, well, I can look at this as one quantity. That is one quantity. That's a separate quantity. Lo and behold, I can use the triangle inequality. So now, here's what we have next. So now we have, this is equal to, we know that the absolute value of x minus y, this quantity, plus y. Well, we already established from our other work that now we can write this as being less than or equal to the absolute value of x minus y plus the absolute value of y. So now we have that. So far, all of this, we have the absolute value of x was equal to this expression, but now using the triangle inequality, we have this quantity and that quantity. We know that this is less than or equal to the absolute value of x minus y, that quantity, plus the absolute value of y. By using and employing our algebraic trick. So don't worry if you couldn't see it at first. Neither did I. Neither did many mathematicians. This had been worked on for a long, long time, of mathematicians working on their own or together, and somebody thought up and says, oh, let's try this. I have an idea. And they stumbled upon it and says, oh man, look at that, that works. So now, since this is that, what can I do now? Let's see, Ramona? Yeah, the answer's kind of here. We're going to need an absolute value of x, aren't we? So what do you think I'm going to do now? Since this and this are the same, and I need this, what do you think I'm going to do now? Take a close look at that. What can I do now? Very good. Well, that means I can say that the absolute value of x is indeed less than or equal to the absolute value of x minus y plus the absolute value of y. Well, notice from here I need to get this by itself. Now I'm going to employ algebra. I want to get this expression by itself. On the right side, who cannot stay there? Jeff. On the right side of this inequality, who cannot stay here if I want this to be by itself? What concept am I going to use to get this by itself? Who can't stay? Who's no longer my friend? Can you tell me who's not my friend anymore? You're right. We can't get along in the same complex together. So he decided, you know, for his peace, I gotta move, man. I can't stay with you. So how are we going to get rid of him? Using algebraic concepts? What concept am I going to use to get rid of him? Can you tell me? What concept? Knowing your concepts is important. What am I going to use? Let's see. Peter? Okay. Additive inverse. I need the additive inverse of that so I can eliminate this. And I'm going to use the additive property of equality, inequality. I'm going to use the additive property of inequality. Whatever I add to one side, I must add the same thing to the other so I do not change the problem. So now, using the additive inverse and the additive property of inequality, I have minus the absolute value of y minus the absolute value of y. And now notice, I have the absolute value of x minus the absolute value of y. This goes, because they cancel, additive inverses, that's 0. And now this is less than or equal to the absolute value of x minus y. So that's our first part. So far we've shown that the absolute value of x minus y is greater than or equal to the absolute value of x minus the absolute value of y. That is the first part. So what I'm going to ask you to do is please pause your video, take your time and copy this work, please. I'm going to try to make room for our next edition, the second part of this. So if you need to, please pause your video right now. Okay, the next step in going and proving and establishing this property, I'm going to separate it this way. The next step in establishing our property, I use the absolute value of x. What do you think I'm going to need to use now? Let's see, Maria. I already used the absolute value of x. What do you think I'm going to use now? Very good deductive reasoning, exactly. Well, inductive reasoning, I'm sorry. I stand corrected. Very good inductive reasoning, your observations, powers of observation. Since I already used the absolute value of x, I'm going to use the absolute value of exactly y. Let's start that. So now I have the absolute value of y. What algebraic trick I'm going to use? I need an algebraic trick. What am I going to use? What did I do over here? I need 0. So now I am going to let this equal to the absolute value. Just pretending that's a straight absolute value bar. It's the most perfect absolute value bar that you have seen in your life. Don't you just love it here with me? I know you do. Now, what am I going to replace 0 with? Yes, very good. So now I'm going to come down And I'm going to have the absolute value of y minus x, and I'm going to put this in parentheses, plus the absolute value plus x. And remember that this is our replacement for 0. Okay? All right, ladies and gentlemen, well, so far, now here's what I have. I'm going to have to do this separately. Now, using the triangle inequality, I have y minus x plus x, the absolute value of that, triangle inequality. What does the triangle inequality tell us? Fabian! Okay? Let's see, Monica, do you agree with Fabian? Just like we did over here? Very good. Yeah, we're going to apply the triangle inequality. Do you agree with that? Are you sure? Let me know by way of email. Well, the triangle inequality states that this is less than or equal to the absolute value of y minus x plus the absolute value of x. Do you agree? Now remember that this whole expression is this, because since I added 0 in, I did not change that, our trick. So this is that. So I'm going to use substitution. I'm going to put this in place of that. So on the next line, here's what we know now. Now I have that the absolute value of y is less than or equal to the absolute value of y minus x plus the absolute value of x. Do you see that? Very good. Well, right now, again, this is not in the exact arrangement, but we're going to deal with that momentarily. I need to get this by itself. Can he stay here? If not, what concept do I use? What concepts? There are two concepts I need if I don't want him to stay there. What are they? Repeat them to me. Look over here. Tell me the concepts. Let's see. Francois, what concepts am I going to use to tell this guy, your lease is up, you gotta leave, bro? Can't stay here. Can you tell me? Very good. Additive inverse. Additive property of inequality. Whatever I add to one side, I must add the same thing to the other. Let's go ahead and do that. Additive inverse. Minus the absolute value of x. Whatever I add to one side, I must add the same thing to the other. Additive property of inequality. Now, upon combining these, additive inverses, zippo, zero, gone, nada, gone, not here. Now, I have the absolute value of y minus the absolute value of x, which is less than or equal to the absolute value of y minus x. Okay, ladies and gentlemen, now I'm going to work on the right side. We're going to use property A. Part A that we just started in the beginning. We're going to use part A on this. Watch. Here is how I'm going to use part A. I bring down the absolute value of y minus the absolute value of x, which is less than or equal to the absolute value minus, I factor out the negative and I get x minus y. Now remember from part A that the absolute value of negative x is equal to the absolute value of x. So from part A, utilizing what we have learned from part A, here's what I know now. I now have the absolute value of y minus the absolute value of x is less than or equal to the absolute value of x minus y utilizing part A. Go back and take a look at part A. I just used part A. That says the absolute value of minus x is equal to the absolute value of x. Remember, this expression represents a quantity, one thing. I can say let x minus y equal z. Don't forget our concepts here, what that is telling us. All right, ladies and gentlemen, I'm going to pause the video. What I'm going to ask you to do is copy this down to this point. I am going to erase this section and finish this and then put everything together. So please, at this time, please pause your video, copy that work. I'm going to erase part of this down to here. Okay, thank you so much, class. Everyone, please copy the work as I clean the board. I shall return. What famous general said that? All right, ladies and gentlemen, I am back. I am back indeed. All right, we are almost there. We need to fix that, though. We need to get this in terms of absolute value of x minus the absolute value for y. So, drawing my separator there. Let's see how can we do that? How can we get these to arrange positions? What do you think I can do to this inequality to get these two to commute their permissions? Permissions, okay, that's good. Permissions. What can I do to the inequality to get these two to commute? The commutative law, so these trade places. What can I do to that inequality so that these two end up trading places so that I get this? What can I do to the inequality to make that happen? What operation can I do to that? Let's see, Lauren. What operation can I use on that so that they commute, they trade places? What can I do? Talk it over with Jeff. Let me know when you're ready. You think it through as well. Okay? Really? Ah, very good. You see that. Excellent. Share with the class. Good. If I agree with that, do you understand what she did now? What both of them did together? See how they collaborated. Do you see what Lauren and Jeff did? They said there was one operation that they knew they could use to get that to happen to an inequality. Can you guess what that operation is? Here's what they said. They said, well, I know that I can take -1 and I can multiply the entire inequality by that -1 because that negative, by multiplying by negative, has an influence on the inequality. And now I get the absolute value of x minus y. Close. So now, as I multiply through by -1, everything here changes sign. When that negative hits that inequality, what does that negative do to the inequality? Let's see. Frank, you had your hand raised. What does that negative do to the inequality? It's like a magnet. It's like taking the South Pole. That needle is going to follow it around. That negative is going to make this inequality change direction. Remember that. It's another common error. As we multiply across, as soon as that negative hits it, it's like introducing the South Pole to a compass. That needle is going to follow that South Pole wherever it goes. So as soon as this hits that, that's going to flip over. Let's go ahead and show that. Everything here changes sign. So now I have the absolute value of x minus the absolute value of y. Okay, that traded places. And now this is greater than or equal to, well, minus the absolute value of x minus y. Ah, very, very good. Well, notice what we have here. Here we have that the absolute value of x minus y is less than absolute value of x minus y, and the absolute value of x minus the absolute value of y is greater than that. So here's what we have now. We have now shown that the absolute value of x minus the absolute value of y is less than or equal to the absolute value of x minus y, and it is greater than or equal to minus the absolute value of x minus y. What do you see? Can you tell me that? What do you see? Florence? Yeah, we can apply again the definition of absolute value to this as well. This is in the middle. X greater than negative a, x less than or equal to a. Therefore, the absolute value of x is less than or equal to a. So therefore, this quantity, we now have established that the absolute value of this quantity, the absolute value of x minus the absolute value of y, this quantity is less than or equal to this, the absolute value of x minus y. And now, using the symmetric rule, remember the symmetric property. The symmetric property says if, we have to remember our properties, if A is equal to B, then we can say that B is equal to A. Symmetric property. So utilizing the symmetric property, we have that the absolute value of x minus y, using the symmetric property, is greater than or equal to the absolute value of the absolute value of x minus the absolute value of y. Bingo! We have established that. Are there any questions, ladies and gentlemen? Any questions? Do you have any questions? Did I do all right in explaining this and getting you to think and having a two-way conversation with you? Did I pull you into the problem? Did I help you to think? Let me know, please. Contact me by way of email or call me to discuss this problem. I'll be glad to do that. Let me know if I pulled you into the problem. Did I make you feel as if you were right here with me, talking to me, and collaborating with the class? Now, if you need to, again, please pause your video. Please copy the work and do as I asked, as Professor Keys told me. Pull up a chair, get a nice, cool drink, unalcoholic, and think through the problem. Take it in. Let me know if I've been of help to you. Have I been clear? Have I helped you to see concepts, properties, laws we have to remember, how to use them? This is going to be the foundation of what you're going to do later on in calculus. This is the foundation of some very important findings that we're going to use. Let me know if I've helped you. Thank you again for joining me, and I hope to come up with another segment to present to you free of building blocks of calculus. Thank you for joining me. Thank you.